ma'am. So in live, so we are live now. So
Okay.
we'll begin after 3 to 4
7
minutes.
minutes.
We can begin. No,
Okay.
after 3 to 4 minutes we can begin.
Okay.
Let's see now. All right, ma'am, we are good to go. So in a minute we can begin. Okay, yeah, we can begin now.
So hello, everyone. Here we are today on another session of Career Stories in Astronomy and Space. I'm Dr. Mila Mitra. With me are Shreya Santra, our special guest today. Welcome, Shreya.
Thank you. Thank you,
And my colleague Arjun Gulia is also here. So for all our students, you've been listening to different stories of, from different people of how it is like to be in the field of astronomy and space sciences and how you get there. So today we'll have a special story from somebody who's almost there. Shreya Santra is doing her PhD now. So we'll hear the story from her side today. So let me introduce Shreya first of all. Uh, she pursued her bachelor's in electrical and electronics engineering at the National Institute of Technology, Jharkhand. In 2015, she completed a master's in interdisciplinary space studies from the International Space University in France. Her interests and specialization include the development of micro rovers and small satellites for space exploration. She also holds an MSc in Space and Engineering Systems in the Skolkovo Institute of Science and Technology, Moscow, Russia, where she worked on high altitude balloons, industrial robots, and small satellite constellations. In the past 5 years, she has worked on various projects related to the optimization of space missions and gained vast experience working with international teams to develop innovative space systems. She was awarded the prestigious Japanese government MEXT scholarship to pursue her PhD in Aerospace Engineering Institute in Engineering Department at the Tohoku University in Japan. Her PhD is focused on swarm robotics communication and coordination for planetary surface exploration, carried out at the Space Robotics Laboratory in collaboration with DLR Institute of Communications and Navigation, Germany, supported by the DAAD research grant. So that's a lot of achievements and probably a lot of technical words for the kids. So we are going to go through it one by one so all of you can understand how she has achieved so much and what all these technical terms mean and how she has come to the point where she is now. So again, welcome Shreya.
Thank you, ma'am. Thank you so much for giving me this opportunity to talk about my journey and from my experiences, maybe guide the students who are interested in space, astronomy, and aerospace engineering. It's really a privilege for me to join here today and getting this platform. Thank you.
So let me start with, how did you first develop an interest in astronomy? I see that you started with engineering and I mean, as many of us know now, that is connected to astronomy and space sciences research. But what first triggered your interest in astronomy or space?
Sure. I have a couple of slides to show my journey and how I got into this sector of space. So I would like to share that. Yeah, so how it all started was I was growing up in the coal capital of India, in Dhanbad. And while growing there, I was always intrigued by the night sky. Science was my favorite subject, and I always knew that I would get into this field in cosmology and astrophysics. And just a fun fact, my nickname is Moon. So it was always there, like I would like to go into this field. But I'm like a typical 90s kid, and we didn't have computer and internet back then. And I was also not aware of like popular media like Star Wars, Star Trek, etc. So yeah, I was pretty much a very naive student, but I really like to read. So I would go to the libraries in school or in public libraries in the city and just look at the beautiful pictures and encyclopedias and Britannica and those things. And I was so like amazed by all of those pictures, and I was like, okay, I think I should pursue this field. And I used to participate in a lot of quiz competitions, and my school teachers and my parents, they were all very supportive of me. Uh, and but this was all like a hobby, and I was a young student, so I was not sure if that's the right path to take. But then in 2003, the Columbia disaster happened, and that's when like I watched the disaster happening on TV, and I was so shocked. Like Dr. Kalpana Chawla, I knew about her before the mission, but after that disaster, it totally shook me, and I started taking this field in more seriously, and I read a lot about Dr. Kalpana Chawla and about her journey, how she started from such humble background, and that inspired me a lot. And then I was like, okay, I have to get into this field and get either in space science or aerospace engineering. And also, I read a lot of books by Dr. APJ Abdul Kalam, and his books were very inspiring and very motivating, of that we can keep dreaming and always make our dreams true. So I'm still in that path, but these are the people who really, really inspired me a lot, and that's how my passion became more stronger.
Yeah, that's great. I hope our students listening to you also get into reading all these kind of books so that they get the same inspiration. And just to let you know, I didn't share that before, but a lot of the students joining us today are actually students who are going to be participating in a space Olympiad with us. So many of them are interested in quiz competitions just like you. So, yeah, so let's hear more about your journey all the way from Dhanbad. Uh, you went to NIT, and then you've got your masters in two different universities. So tell us a little bit more. In fact, please do share information a little bit about the colleges, also the universities, so the students can know possible locations that they can go to when they follow this career path. So yeah, do tell us a little bit more about your educational journey.
Mhm. Yeah, so I also have some visuals for my journey. So as I said, I was in my school in Carmel School in Digwadi in Dhanbad, and during those years, I was mostly like reading a lot of science books and reading a lot of participating in quiz competitions and all. And of course, we have to give the board exams. So I appeared for board exams, and I did very well. And but I was not sure if I should get into astrophysics and like more pure science or engineering. Uh, but I went with the flow, like a lot of family and friends were going into engineering. So I went into engineering, and I enrolled in electrical and electronics engineering at NIT Jamshedpur in India. I did consider aerospace engineering, but I was not sure which universities were really good back then. This was in 2010, so I was not sure. So I just went with the flow for NIT, which was a good institute.
Right.
So I I enrolled there, and during my 4 years of my bachelor's, I was pretty sure like after my bachelor's, I will go for more space dominated masters. And so during those 4 years, I was doing a lot of online courses on satellite engineering and aerospace engineering, and also like I was kind of looking for uh, contacts in NASA or ESA and other space agencies. But I had no one to guide me, and I didn't know which paths to go forward to. But during my third year during my bachelor's, I got into an internship at the Indian Institute of Astrophysics in Bengaluru. And that's where I got to meet people who were actually working in space because before that I had no idea and I didn't know anyone who was working in this sector. So I met scientists and I met students who were studying, doing the research and space related domain. So through them, I got to know about International Space University, which was in France, and I looked through the website and I was like, wow, this is a great university and this could like give me a platform to get into this sector. So I applied for it, and the curriculum in ISU, it's interdisciplinary space study. So they give you uh, knowledge about everything about space. So I learned about space law, space policy, space engineering, space business, space science, and everything. So it was very, very interesting for me to know everything about space, and I got to work with so many people from different all over the world, and I met so many people. I met so many astronauts. That was really a dream come true. So, and since then, it has been a whirlwind ride. So, from the networks that I made at ISU, I decided that I should do a more technical master's, and that's why I went to Skolkovo Institute of Science and Technology in Moscow. And a lot of people ask me, why Moscow? Why did you choose Russia? But it's because Moscow is amazing. Like the city was amazing. They have amazing space heritage from the Soviet space era. And when I was there, I was so amazed by all the big rockets and big statues of cosmonauts all around.
And they have a
And
big
I,
space center there, right?
yes,
Yeah.
yes. So I visited the Star City and where astronauts train and all of those places, and it was very, very inspiring for me. So, and there I did 2 years of my master's in space and space systems engineering, and I specialized in the, robotics. And I also worked on stratospheric balloons and small satellite designing and stuff. And during that time, I also got to do some internships in Netherlands and Luxembourg and different places. And after my master's, almost when I was ending my master's, I applied for this mixed scholarship from Japanese government and for my PhD in space robotics lab. I will tell more about my lab later, but this is the university, Tohoku University, and here I'm doing my PhD right now in swarm robotics and in coordination with the German Aerospace Center. So currently I'm on a 6 months exchange in Germany, in German Aerospace Center in Munich. So this is my journey all the way from Dhanbad, all over the map. And currently I'm in Germany. And after, I don't know what I'll do after I finish my PhD, but yeah, I'm still carving out my path. So as you can see, like all over the map, I also got
That's great.
opportunity to go to NASA JPL for some time and work on projects.
So was that NASA JPL an internship, or that was part of your master's projects?
It was part of during my PhD. I went for a few weeks at Caltech JPL to work on to attend basically some workshops and summer school for my PhD.
Yeah, so the map looks amazing. It's great that you've had the opportunity to be part of different institutes and be in different locations. So I just wanted you to talk to us a little bit more about ISU before we move on, because it sounds interesting about different fields of space. There, you use a space law, space policy, and space technology. So, just tell us a little bit more about ISU.
Yeah, sure. So International Space University, it's located in Strasbourg in France. It's like on near the border of Germany. So they have a very interesting curriculum, which gives the students a very holistic idea about space. Because, for example, for me, when I went there, I had no idea about which stream of space should I choose, and that 1 year at ISU like introduced me to all the options, and then I had like more idea of, okay, this is the thing I like, and this is where I should get into. Similarly, like a lot of my batchmates during that year, they were from all over the world, and they were from different disciplines. Some of them were from space discipline, some of them were completely like non-space people, and they were coming from law, and they were coming from business side, and so all of us worked together and studied all the different space related subjects. And after that, they got into the space sector in the topic that they like, in the field that they like. So like, for example, someone came from a from engineering background and really liked space business, and then got into space business and is in a very high post right now, promoting their startup or the companies. So
Right.
that's what ISU does. The ISU has programs. I suggest like all of those watching to check out their website, and they have different programs and short ones as well, which are like 10 weeks. And then there's also the master's program, which is 1 year. And they also have scholarships, especially for Indian female. Uh, they have scholarships. So definitely check out for the scholarships if they are interested in applying to ISU.
Yeah, that's great. I mean, I know you and I have mutual friends who are in entrepreneurship and have started their own companies who are from ISU. So that's great for the students to hear about how you can get a foothold in something like that. Okay, so you talked about your PhD project, and you've been interested in swarm robotics and planetary surface explorations. So let's hear a little bit more about that. What is your PhD? What is your research? And what do these words mean so that the kids can understand more of the topics?
Yeah, sure. So briefly, I will introduce my lab, which is the Space Robotics Lab in Tohoku University. It is led by Professor Kazuo Yoshida, and he's pretty well known in the space and robotics sector. So maybe some of you know about the Google Lunar X Prize, and there were like 5 finalist teams
Right.
in there, and one of the team was from this lab, from my lab, which was Team Hakuto. So you can probably, I'll show you.
And this is the same where Team Indus was also one of them, right? Yeah.
Team Indus was one of them, and Team Hakuto had a deal with Team Indus to use their lander. So they were supposed to piggyback on the Team Indus lander. But yeah, as we know, like the competition was called off. So anyways, the rover was pretty good, and it's pretty well built. So they had a spin-off from the lab, which is now iSpace, and they are now building rovers and landers for lunar exploration. But my lab is like we conduct a lot of studies on locomotion, navigation, and control strategies for various types of robots to be used in space environment. So you can see like a wheel robot, then there's the limbed robot, like robots that can walk, Then there are robots in the orbit, which can be used for docking and also for servicing of different satellites and systems. So also asteroid exploration robots like Hayabusa 1 and Hayabusa 2.
Right.
Some of the systems were built in my lab. So yeah, we do a lot of collaboration with the Japanese aerospace center with NASA, as well as the German aerospace center. So yeah, we are all over. When it comes to space robotics, this is like one of the best lab in the world. And my work is working on swarm robotics. Swarm robotics mean like having multiple rovers or multiple robots to explore a region. As you can see in this picture, like instead of having just one robot, we can have multiple small robots, and that has a number of advantages. First of all, they can be like redundant, so you can have more number of robots exploring the same place, and you can also like explore larger areas having multiple robots. It is also highly like cost effective, because you don't need to have one big robot but have multiple robots having different capabilities. It definitely is cost effective, but one of the challenges in this is the coordination between these multiple robots. So that's my topic for PhD, and I work on this is my team, and we had a demonstration to one of the Russian astronauts who were visiting our lab. So we work on different types of small robotic platforms for like coordination and localization and mapping. We use different kind of sensors to give these robots enough capabilities to travel around autonomously. And also, like, my specific topic is to have communication between these agents so that they can navigate themselves. For example, say for example, just in real life, you plan something with your friends, but you plan to go to the movies, but then there is a miscommunication between the friends, and one of them goes to the movies, one of them goes to the restaurant, and then you're not able to reach your goal. So
Right.
that's what I want to implement in my robots, so that they can share information in an effective way. And I'm modeling the communication architecture between these robots so that they can share this information and navigate in a planetary surface. And here, planetary surface, I mean like on the moon or on Mars.
Right.
So yeah.
Okay. That's great. And I can see that your experience in engineering would have really helped in doing all this work with robots and communication. So you were off to a good start. And yeah, so I just wanted to ask you, we've also interviewed a professor last time, and he was talking about the kind of things a professor does. And now this time we have you, who's on the other side of the table. And I wanted to find out from you, what do you do in a day in your life? What kind of things do students in doing graduate programs do in general?
Yeah, sure. So most of my time during the day goes in reading a lot of scientific papers and journals to know what has already been done in this field and what are still to be solved, because there are a lot of challenges to be solved, but it's very important to get into like details of that. So I read a lot of papers, mostly. That's like a major part of my day. But Also, I do a lot of coding and experiments, coding mostly in MATLAB and Python languages. So yeah, and usually the days that are fixed for experiments are mostly very hectic because there's a lot of things that can go wrong. Like coding and theoretical part is okay, but when we start implementing it on the robots, then everything can go wrong and you have to start troubleshooting and think, okay, like very very simple things can also fail during the experiment. So yeah, that's one of those like hectic days when you have to do experiments. Other than that, I also have to spend a lot of time doing writing papers for publications in conference and journals because it's a very important requirement to earn PhD, and that takes a lot of time as well. For me personally, I don't really like writing, but I have to write. I have to make myself write. So yeah, and other than that, we have to take some classes and also teaching assistantship responsibilities, but those are not a lot. There are some certain credits that we have to earn. So we take that course, and yeah, usually we try to finish it in the beginning of our PhD. So that's like a short time, maybe the first semester. Other than that, so this is the typical day in a working day. But other than that, during the weekends, I do a lot of voluntary projects. Like I'm involved with some voluntary organizations to do to write papers related to space exploration. I'll talk about that later. So yeah, I do some STEM and outreach activities. Also, I like to travel a lot. So I have been to so many countries and I want to explore more of those places. So I travel during the weekends and yeah, try to pursue my hobbies. So yeah.
Yeah, I keep seeing photographs of you at different locations, traveling, and also you're also interested in dance. And so I think that's a lesson for everyone, that all the students that uh, don't shy away from hobbies, even if you're a science engineering student, do keep it up because that's going to enrich your life. So yeah.
Yeah, we
So
definitely need some time off work to really relax ourselves. So yeah, hobbies are great.
and experiments, I guess you work in groups. So there's a lot of group dynamics, and it's not just working in your own location, right?
Yes, that's right. All the work has to be done in group because I am only working on one particular topic, but my teammates are working on other different topics, and all of us have to work together so that the systems work. And the interfaces between the systems should be like should be robust so that they can work together. So all group dynamics, no miscommunication. Of course, there are some miscommunications in team working, but we have to come up with a solution and definitely make everything work.
Yeah, that's very good experience, and you know, it gives you the experience of working with different kinds of people in different fields. So So tell us, Shreya, more about what is your advice to these students, and what are the kind of skills they should build up and the kind of paths they should follow, so that they can also think of a career in space physics.
Yeah, sure. So for from my experience, coming from a very uh, like a naive background, not knowing anything much about space. But I think a lot of students now are already ahead. They have a lot of access to internet and a lot of information, a lot of online courses and networks and things like that. So what I think is like other than just studying or from the curriculum or the books, textbooks in school, I think it's very important to develop logic and systems thinking capabilities. So for example, if we want to get into science and engineering, we need to solve a lot of problems. And for that, decision making and logical thinking is very important. So we should like imbibe or implement these skills for our future. All the students should learn some like do some activities which can develop these kind of skills. Other than that, systems designing is one skill that students should learn about. System designing sounds very sophisticated, but what exactly it means is like, even if you are building a small robot, or if you are fixing a telescope or something, so you should know how each of the interfaces work, how each of the parts or the components of that system is working, and how all of them come together to work as a proper system. So that's one skill that we should have while growing up. Other than that, of course, like it's very good to have some programming language language knowledge. Of course, there are many different kind of programming languages, Python, C++, and so many, and they keep on changing and evolving. So you don't need to like know all the languages, because all the logic are the same. You just have to kind of practice or any one language, or try changing when you know, like, okay, you have mastered one language already, then you can try learning another one. And if you're really interested in space, in robotic systems and space robotics, maybe you can take some courses in edX or Coursera or Udemy, and try to like learn from that. But this is a bit more advanced. It doesn't have to be during your school time, but you can do it later. And the most important thing is like the 3 P's that I say: be patient, persevere, and like be very passionate about what you want. For me, it was just my passion that brought me all the way from Dhanbad to here. So I think like definitely be passionate about your dreams, and keep dreaming and never stop learning. That's what Dr. APJ Abdul Kalam always said, like always work hard towards your dream. And there are a number of universities that in India, in Japan, in US and Europe that you can enroll into for your higher studies for space robotics or aerospace in general. If you can see, there is a small QR code on the corner. That's a list of universities that I have prepared that have some courses on space robotics or robotics in general.
Okay.
So yeah, you can check those. Definitely check in the university websites. They have different requirements, like maybe they require a TOEFL or GRE, etc. for admission. So just check into each of the individual websites. But always look for opportunities. Keep even if you are say, for example, you get into a field that you don't like, but try to pursue that field in a way that you can use it later for your own dreams. So like electrical and electronics, I was not really interested in electrical engineering, but I knew that somehow I can use my electronics knowledge later for building satellites or robots. So that's how it went for me.
And yeah, thanks for sharing so much advice about how they can proceed. And I think by a lot of today's students know that they should go into which fields of programming. But your advice on robotic operating system and some of these things was very valuable. So I just had a couple of questions. That what's the mode of applying to universities in Japan? I'm sure a lot of these students know about the US, or they can find out about it. But what about Japan? Do you have to take a separate admission exam for that entrance exam?
Yes. So the first thing in Japan is you have to contact the supervisor of the lab that you want to work in. So it's both for masters as well as for PhD.
Right.
So you have to contact the professor and convince the professor that you are interested in the topic that his or her lab is working on, and then you develop a research proposal that is then like submitted at the university. And of course, it's always good to enroll with a scholarship. So Japan has a couple of scholarships for international students, like the MEXT scholarship. Then there's JICA, JICA, JICA scholarship. So these scholarships you can apply through. But first thing is contact the professor, and then form a research proposal. Usually the universities are not so consistent with the admission procedure, but they do have a test, but the test is mainly for the scholarships.
So, you're one of the few women in robotics or STEM. And as you said, there's also a scholarship that ISU is giving to women in STEM. So what has been your experience? Do you feel comfortable, or do you feel you have to work? When I was there doing my PhD program, my advisor told me that you have to work twice as hard to be taken half as seriously as the men. So do you feel that's still true, or you're much better accepted? And what do you advise for the young girls who are our students right now?
Mhm. I think it's still partially true, because a lot of places where I work, I'm like the only girl working, and I'm like, okay, when a lot of men are speaking and you are kind of, silenced down. So that's, I have definitely experienced that. Maybe they don't do that intentionally, but definitely it happens. And it's very important that we know that we girls can do equally good like boys, and we should not be afraid of like voicing our ideas and opinions when we are discussing in a team or discussing something important. And we need to work hard, not just during PhD, but also before that, like even during engineering, during bachelor's, you have to like really make your mark,
Right.
to show that, oh, you can do it. So unfortunately, that's the world, and it's true all over. I have been to so many developed Western countries, and it's the same. So I think it's very important that we ourselves are confident of our knowledge, and we keep working hard, and ultimately people will notice us, and we should take ourselves seriously before we expect others to take us seriously.
Yeah, I think that's the point, that our young girls have to be as confident in what they're doing, and then everybody will notice you.
Yes.
So with that, Shreya, I think you've covered a lot of interesting points, and what the students can do. And I know a lot of them have questions for you. So this might be a good time to bring in some of those questions. So Arjun, uh, could you bring us some of the questions from that the students have been posting?
So yeah, yes, ma'am. So thank you so much, Shreya. So that was very inspiring talk that you're talking about. So yeah, so we have been getting a lot of questions from the students. I'll be happy to take a few of them to you. So let me just start by asking a question from it is Shubham Agrawal. He says that, ma'am, I want to become a person who studies the data from telescope. So which degree should I pursue?
I think it's more into observational astronomy.
Right.
So
Yeah.
yeah, I have a lot of friends who are in this field, and it's not just the small telescopes, but they are actually working with telescopes in Chile and in other areas remotely. They are controlling these telescopes and taking data of galaxy and nebula and all those great things in the universe, and they are studying these and trying to identify if there is any anomaly, or trying to identify new planets and galaxies, discovering new galaxies. So I think it's observational astronomy. I think there are many other sub fields in this overall field. So yeah, you have to carve out which one you are more interested in.
Okay. Yeah. So yeah, that is something we can look at, but don't forget to look at the QR code that Miss Santra sent. That it also
Right.
will help you a lot in finding out the course and the universities, which will help you in your future pursuits.
Right.
The second next question that we have is from Arya Niravati. So he asked that, can you explain more about Dragonfly Rover? He wants to know about that.
Okay, yeah. You mean the rover that's going to Jupiter, Jupiter's moon, Titan, I think.
I think so. Yeah,
So
that's the
yeah.
one. Yeah.
So it's not a rover, but it's a, lander plus like a drone. So Jupiter's satellite, natural satellite. Jupiter has many natural satellites, and one of that is Titan. So, and Titan is supposed to have very dense atmosphere. So, if there is a dense atmosphere, which means robots can fly there. So Dragonfly, which is being developed by NASA and Johns Hopkins University, they this has like, it's an octocopter, so it has 8 like the rotors to fly and explore around in the Titan surface, and click pictures and send back.
Okay.
Okay.
Yeah. So the next question that we have is from Praveen. Parveen Turna. So he's asking that, what was the best you found in your lab?
Best I found in my lab.
Yeah.
Okay, the best thing I found in my lab are the people. The people are very good, because even if you are very intelligent, there is always something that you get stuck in. There's some problem, and then you start looking for the solution on internet or something. But often I have seen, like, if I talk to my teammates, if I talk to my seniors, they have a different idea, and it makes it easier to solve the problem that I'm stuck in. So I think the people are very uh, important with whom you work. Uh, that said, of course, I like working on robots, and uh, the best thing I like is like trying to solve some problem or why it's working, and like spend nights trying
Right.
fixing.
Yeah. So we have a couple more questions about the courses from students. So Arya Niravati, again, he's asking, which universities and courses is best if you're interested in astronomy and astrophysics?
I think there are a lot of universities in the US which has very good astrophysics courses. In India, I know Indian Institute of Astrophysics. They have
Right.
very good research, and they do a lot of like collaboration with many different foreign universities. Um, yeah, I think also. IISc, maybe Indian Institute of Science in Bangalore. They have good astronomy courses.
And Ayuka also, like I had pointed out
Ayuka,
last time.
right?
Yes.
And
Yes.
I'll just add to that that as Shreya mentions in her list, definitely Caltech is a good place, and Harvard and Johns Hopkins is where, in fact, the Hubble Space Telescope was part of Johns Hopkins before. But there's also Berkeley University, University of Chicago, and so some of these are good names that you can go for astronomy and astrophysics research, but you can probably look it up on the web. There are a lot of places that do the research, and as you might know by now, you can do all the way from observational astronomy to experimental to data analysis to solar physics. So you'll have to kind of to planetary space physics. So you'll have to figure out what is the best kind of field that you are interested in, because depending on that, you might have better research at different universities. Yeah.
Hmm. So yeah, so again, like I was saying, we have one more questions regarding to the careers. So it is from Ritu Kansal, and she is asking that, ma'am, I want to be the one who goes into space and studies, and that info which we get from spacecraft. So which degree should I go for? So basically, she's asking that if she wants to go into the space and get the data from all the missions that we send into the space, or what degree should I go for in that case?
So for that, there are multiple degrees. It depends on what kind of data you want. You can become a biologist and then probably become an astronaut and then go to space and study how human body, like study medicine and how human body reacts to space conditions. You can become a geneticists, like work with genes or microbiology and take these samples and study how these are affected by the environment. Or you can study engineering and then like build satellites and see how satellites are working in space and how or build robots and take these to Mars or Moon and try to like how these systems are performing in space. So there are many different kind of uh, fields that you can get into. It's just like what you are interested in, one particular topic that you are interested in, and you need to recognize that.
Right. Or it might even evolve if you've built up the right skill sets, like Shreya advised, in programming and in engineering, and you have your base of astronomy and space physics courses. Then wherever you end up, you might be guided from there itself to be part of the projects that they are involved in, and that might actually determine how you move on into that career. So yeah, there are many missions that send back data to ground itself, to ground research universities and laboratories. And if you work in any of those places, then in any kind of discipline, be it engineering or as a scientist or a support engineer, then you would be working with the data that comes from those missions. Yeah. And some of these missions even have public data, so you as a scientist can apply through a proposal and get hold of the data and do your research with that as well.
So yeah, ma'am. So I have a couple of questions more that the students are repeatedly asking. So if we have the time, I'll just take a couple more questions. So one question is from Varsha Mane. She's asking, ma'am, which programming language can we learn for astrophysics and other astronomy fields in general?
I think now it's mostly Python, which is very popular in engineering and astrophysics and everything. Also, I know in astronomy, they also do a lot of Fortran language. So Fortran is very old, but one of the most useful languages because a lot of supercomputers that are used for processing astronomical data, they use this language. So you can learn Fortran. Yeah, I think, as I said, like you don't really have to learn all the languages. You just have to have the logic behind how the things are working and how you can take decisions and how you can solve a problem. So I guess.
And I think you mentioned MATLAB before. That's also very useful in scientific research.
MATLAB.
Yes. All right. So with this, I guess we are through. So I just wanted to take one more question that is from Sunil Rana. He says that, ma'am, I'm confused between astrophysics and astrobiology. Which one should I choose? Because I'm interested in both the alien life forms and the space exploration. Yeah, so that is basically more of a personal choice, but yes, you also can give your.
Yeah, so astrobiology is becoming very popular nowadays. It's a very interesting topic.
Right.
And yes, it depends on what your interest is. If you are interested into more of physics and cosmology and astronomy, or if you are interested into studying life forms and studying chemistry and trying to detect the different biosignatures. But ultimately, from what I have studied and what I have seen, space is very interdisciplinary.
Right.
And I know so many people who have changed from, who started from astronomy and then moved into astrobiology and now working with teams which are like mixed members. So definitely, you don't have to be restricted to just astronomy. You can take one path, and you are just in, say, in your school now. You still have so many years ahead of you.
Right.
So uh, like maybe you study astronomy and then later you get to meet people and you form a team and then you move into astrobiology studies. So yeah, you don't have to restrict yourself, definitely.
Yeah, that's a good answer. You can always switch from one to the other because you would have the necessary skills by then to move on.
Yeah.
Yeah. Okay. So yeah, thank you so much, ma'am. So I guess that will be all from our end.
So
Yeah.
yeah, so
I
Shreya, any
have,
last yeah?
yeah, I have a slide that I would like to tell, like just as from all the questions, it was very good. All the questions were great and I really enjoyed answering those. But what you can do now is like stay in the loop and try to build networks and get more and more knowledge and information. There's a lot of opportunities out there, and you just have to look for the right opportunity. So these are some of the organizations that I know of, and I'm also part of the Space Generation Advisory Council, which has many project groups. Well, this is mostly for students who are over 18 years of age, but the other organizations are for school students as well. So you can join these organizations, attend like different webinars and workshops of these organizations, and then you can be more aware of what's going on in this sector, and you'll get to know more and more things about it. So definitely check out and stay updated and stay in the loop and build your network and get to know more people who are working in this field, who have switched from engineering to science or switched from astronomy to astrobiology. So you'll get to know more and more people, and then you'll not feel isolated, or you'll not feel like, oh, you are the only one doing this. You'll feel more connected.
Yeah, so they made a good start by joining us, and you haven't put our name in the list, STEM&Space. So next time
Okay.
I'll
I thought
send you.
it's like STEM. And yeah.
Right. So I'll send you our logo too. But yes, all these students have joined our forum now, and STEM&Space, and they are we are hoping to mentor them for the next few months while they get ready for giving the National Astronomy Challenge with us. That's like an Olympiad. So from that context is how we are introducing them to different specialized space people in space like you. So thanks again for joining us. That was really a wonderful talk. You covered everything from different careers uh, to all the different institutes that you've been to, and you've just shared this photograph of just the same kind of feeling that they can get, of being a part of different institutes, all world known. And thanks again for sharing the kind of skills and subjects and programming languages, and of course, patience, perseverance, these qualities so that they build up as they get into this career. So thanks, Shreya, for being with us today.
Thank
Thanks,
you so
Arjun,
much.
for hosting the questions.
Thank you, Arjun, and thank you, Mila ma'am, for giving me the opportunity. And they can reach out to me through LinkedIn or ResearchGate if they want to.
Okay, great. So at the end of this talk, I'll also share your coordinates with them, your LinkedIn and public profile, so that they can reach out to you or follow you. Okay.
Yeah, sure.
Okay.
Thank you so much, Shreya. Yeah.
So
Thank you.
thanks students for joining us today. And we do have another session in the next day after tomorrow. So we hope you'll join us again. We'll let you know about that. And with that, I think we've learned a lot for today. So goodbye, everybody. And thanks for joining us. So thanks, Shreya, again for joining us today.
Thank you.
And yeah, I think this would have been very valuable for the students.
So, ma'am, I'm closing in a minute because there is a delay on YouTube now.
Okay. Yeah.
Yeah, it is ended, ma'am.